Hey guys, all right, this is video number 27. This is chapter 6, section 4. All right, this is about finding roots and multiplicity. And you've already we've talked about the finding roots part. This gets a little bit more into that. And then it goes backwards, actually. So this should be a fairly short video, I hope. But the first statement is, it says x-intercepts are found by setting factors equal to 0 and solving. I think that you know that. But here's a basic. It says find x-intercepts in f of x equals 3x times x minus 3 quantity squared times x minus 4. And some of you might be inclined to actually multiply this whole thing out and then like get a big old binomial. You don't need to do that. This is already in factored form. So you can take this thing, right? Here's a factor, and here's a factor. So you can set each factor equal to 0. And solve. So let's do that. We'll take this first one. Well, 3x equals 0. You're just going to divide by 3. And x is going to equal 0. This one, now, because of this squared here, we're going to actually take the root. So this means there's going to be 2 of these. We're going to have to take the root to undo that, right? So that will undo this. But this squared means that there will be 2. Of whatever answer we get. So now we just have x minus 3 equals 0. So we have x equals 3. But this happens twice. Which means it has a multiplicity of 2. That's mathematically how you would say that. Okay, so when you do this, you cannot, it is not enough to say x equals 3, because I'll show you why when we're all done here. No, I'll tell you now. If you need to have, let's say your leading coefficient is something x to the 5th, and you say, I have x equals 0, x equals 3, x equals 4, and maybe you get one more. That would be 4 roots, but you needed 5. I need to know that you know that this happens 2 times and that it accounts for 2 of these 5 roots. Okay, you need to tell me that. So you can't just say x equals 3. You have to indicate either by saying x equals 3 and x equals 3, or say x equals 3 with a multiplicity of 2. So you are aware that it happens 2 times, okay? I need to know that you know that it's happening twice. That's important. I hope you're listening with sound on so that you hear that happen. All right, and then this guy, x minus 4, you're going to take that, let me switch my pen color, and just swing the 4 to the other side. Okay, so the answers to this are x equals 0, x equals 3 with a multiplicity of 2, and x equals 4. And if this thing was all multiplied out, here's an x squared. So 1, 2, 3, 4. You should have 4 answers to that. Okay. So that's one problem that you're going to encounter. All right. Another one. This one goes backwards, I think. I only just glanced at it. I did these notes a long time ago. All right, so this is a problem in varsity. It says find an equation. You have to find an equation. It's going to go backwards. Find an equation with a solution of x equals -3, and it has a multiplicity of 1. That means it happens only one time. And a solution of x equals 4 with a multiplicity of 2. Okay, and that's all it says. And it says write your answer in standard form. And so what that means is you have to make sure that it says equals 0 at the end. Okay, so if we have something that says x equals 3, this piece of information, -3, sorry, then you need to write it as a factor. Well, to write it as a factor, you need to swing that over there, and it's going to become a factor that looks like x plus 3. Okay. Also, we have one that says x equals 4. Again, write it as a factor. Okay, well, you're going to swing this over here, and it's going to become x minus 4. But we know this guy has a multiplicity of 2, so there's going to be 2 of these. Okay, so now what you have is you have all 3 of these binomials. So these 3 binomials, this guy, this guy, this guy, x plus 3 times x plus 4 times x plus 4 equals 0. Now you need to multiply this all out and write the equation. So we're just going to FOIL and then FOIL again, essentially. Okay, so if I were to, oh wait, I missed some signs. Did you catch that? These should be minus signs here. All right, so if I multiply these 2 binomials together, I'm going to get x squared minus 4x plus 3x minus 12. And then I combine like terms, so I get x squared minus an x minus 12. And then I'm going to bring down this second binomial times x minus 4. Make sure you keep the equal 0 on it. That guy's super important. So now I'm going to change my pen color, and I'm going to get x cubed when I multiply minus 4x squared. Then I'm going to deal with this guy. So minus x squared plus 4x. Then I'm going to deal with this guy. Minus 12x plus 48 equals 0. Make sure you combine like terms. So I'm going to get x cubed minus 5x squared minus 8x plus 48 equals 0. And this is the equation. Like it said, find an equation. Find an equation. That's what I did. With a solution of x equals -3 with a multiplicity of 1. X equals -3 with a multiplicity of 1. And a solution of x equals 4, which would be x minus 4, multiplicity of 2. Okay, so we worked backwards. We started with the solutions, turn them into factors. Start with a solution, turn them into factors, multiply everything out, get the actual equation. All right, so that's how that's going to work. Okay, so this next one is a little bit of a time taker. Well, it looks wordy in my notes. I don't know how it's going to go here, but let's see. So it says solve the polynomial, but this is the last one. And this might be what this whole thing is about. I don't know. F of x equals, I don't know if I have enough space here. X to the 5th minus 12x to the 4th plus 45x cubed. So my daughter and my grandson are on their way over here. I hope they don't get here while I'm recording, or my dogs are going to go crazy. Everything, it's going to be a mess. So we're going to have to hurry. Minus 192x plus 288, oh my gosh, equals 0. Okay, so what we are going to do, we're going to solve this whole thing, which means we need 5 answers, right? We need to have 5 answers. So where the heck do we start? All right. Well, here's a hint. If you go and graph this thing in Desmos, like graph it in the graphing part of Desmos, then you can find x-intercepts that will save you a ton of time, because your other option is to find p's over q's. And granted, your q is only 1 here because there's a 1 in front of the x to the 5th, but you're going to have like 500,000 p's because 288 is going to have a lot of factors. So if you go graph this thing in Desmos, which I will hook up my laptop and go do and show you how that's going to actually work. I need my keyboard. All right. Let's go pop this guy in there. Here. We'll go to the graphing calculator. I have chipmunks that run my internet at home. They are very slow. They should run faster. That would make this work a lot quicker. Really works my patience sometimes, but that's how it is. It's the best I got. So I can commiserate with some of you who tell me you have slow upload speeds at home. Oh, Lord, I hope this works at all. It should have loaded by now. Okay, so I'm going to graph this function, which I have on my paper, which you can take a look at. So I have x to the 5th minus 12x to the 4th plus 45x to the 3rd minus 22x squared minus 192x plus 288. All right, so take a look at this. This is nice. All right, so I have oh, that's not even a whole number. That's not as nice as I thought it was going to be. All right. -2. Oh, this is not. Did I type the right values in here? -12, 45. Now, oh, I did not type the right numbers in here. This should be a 22. Okay, that's better. Okay, so we have -2 is going to be an answer. So we're going to use some synthetic division here. And then 3 and 4. So just kind of jot those numbers down on your page. -2, 3, and 4. That's what we're going to use when we do these. -2, 3, and 4. Okay, so let me show you what we're going to do with that information that we gathered in Desmos. Okay, our goal when we solve one of these things is to use the roots to do synthetic division as many times as we need to get the problem to a quadratic. Okay, so we are going to do synthetic division. As many times as necessary to get the depressed polynomial to a quadratic. Because we know how to solve a quadratic, right? We can either factor, we can use the quadratic formula, blah, 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 blah. All right, so let's start here. We're going to do the first one. We have a 1 here, so we're going to go 1, negative 12, 45, negative 22, negative 192, and 288. Leave a line, draw a line, drop the first number, and I'm going to put this negative 2 into the first one. And so when we do this, we get a negative 2, negative 14, positive 28. This gives me a 73. This gives me a negative 146. This gives me a negative 168. This gives me a positive 336. You wouldn't believe this is going to happen, but it is. Positive 144 when I add down. Negative 288, which gives me a 0, which means that is a factor, right? Now, this is my depressed polynomial. We haven't done a ton with these, but this guy is really, this started out as x to the 5th, x to the 4th, x to the 3rd, x squared, x constant. This is now x to the 4th, x to the 3rd, x to the 2nd, x constant. We're going to use those values and we're going to do our synthetic division again. We're going to use the 4 this time. I'm sorry, we're going to use the 3 this time. We're going to go in the order that I wrote them in. Use the 3, so we're going to drop the 1 and multiply. Add down, we get a negative 11. Multiply, negative 33. That's a positive 40. Multiply, 120. That gives me a negative 48. Multiply, that gives me a negative 144. Remainder of 0, which means that guy, the 3, is a factor. Okay, well now, if I look at here, this is my new depressed polynomial. And now this is x to the 3rd, x squared, x, and a constant. And I'm going to use that for my new synthetic division. And now I'm going to use the 4. So we're going to drop the 1, multiply. I get a negative 7, negative 28, positive 12. 4 times 12 is 48. I get a 0. So now I have a quadratic. 1x squared minus 7x plus 12. And wouldn't you know it, I can factor this. Now you have a quadratic. And you should look to factor if you can. And I can. In fact, I'm not going to do X method. You guys should be able to factor this thing in your head by now. I can go x minus 3, x minus 4, and that's set it equal to 0. Set each factor equal to 0. So look at what happens. I get x equals 3 and x equals 4 from here, but I also had x equals 3 and x equals 4 from the graph, and then I had x equaled negative 2. And because we aren't spending time graphing in this class, I haven't really spent a lot of time talking about graphing. But when we have a root with a multiplicity of 2, on the graph, it bounces off that point. And this one also had a multiplicity of 2, right? X happened, 3 happened twice. And again, on the graph, it bounces off that point. If it only happens one time, then on the graph, the line is going to cross through that point. So I'm going to real quickly just go back to, so let's look at 3 and at 4, it bounces off of it. At -2, it crosses through it. Well, look what happened when we went there. At 2, it crossed through it. At 3 and 4, it bounced off that point. It didn't cross through it. And so there's a lot of information that you have. I mean, I know I'm a math geek, but it's pretty cool. And if you actually go through and take some more math classes, this is stuff that you should know. So those things will actually pop through and pop off the graph if you have a multiplicity. So it tells you information about the graph if you know that kind of stuff. So that is, like I said, this is the goal of this class, is to get you to get a big old long thing like that and be able to have the tools to go through and solve it and find all the values of X for the entire thing. It's kind of neat. All right, that's it. I'm off my soapbox. Toodaloo.